Hey everyone! Today, we're diving into deep learning for natural language processing using LSTMs. Pushpin Step 1. Importing libraries. First, we need to import our libraries. We use TensorFlow and Keras for deep learning, NumPy for numerical computations, and Matplotlib to visualize our results. These will help us build, train, and analyze our model efficiently. Pushpin Step 2. Loading the IMDB dataset. Now, let's load our dataset. IMDB provides a large collection of movie reviews, each labeled as either positive or negative. Since text data can be quite large, we limit our vocabulary to the top 10,000 most frequent words to make processing more efficient. Pushpin Step 3. Pre-processing the data. Text reviews come in different lengths, so we need to make sure they all have the same size. We use padding to ensure that each review is exactly 200 words long. This way, our model can process them consistently. Padding shorter reviews helps in maintaining uniformity, while longer reviews get truncated at 200 words. This step is crucial for handling text in deep learning. Pushpin Step 4. Building the LSTM model. Now comes the exciting part, building our model. We start with an embedding layer, which converts words into numerical vectors. This helps the model understand the meaning of words in a more structured way. Next, we add two LSTM layers, one with 64 units and another with 32. These layers allow the model to understand the sequential nature of language, capturing patterns and context within the text. Finally, we use a dense layer with a sigmoid activation function. This outputs a probability score between 0 and 1, helping us classify reviews as either positive or negative. Pushpin Step 5. Compiling and training the model. Once our model is built, we need to compile it. We use the Atom Optimizer, which adjusts the learning rate dynamically for better training. Since we're dealing with binary classification, we use binary cross-entropy loss. Now, we train the model for 5 epochs with a batch size of 128. This means the model processes 128 reviews at a time and updates itself after each batch. Pushpin Step 6. Evaluating and visualizing results. After training, it's time to analyze our model's performance. We use Matplotlib to plot the accuracy and loss over each epoch. Ideally, we want the training and validation accuracy to increase while the loss decreases. If the validation accuracy starts dropping while training accuracy keeps rising, we might be overfitting, meaning our model is memorizing the training data instead of generalizing well. Pushpin Final thoughts and next steps. And there you have it. We've successfully built and trained an LSTM-based sentiment analysis model for IMDB reviews. But this is just the beginning. Here are some ideas to improve it further. Keycap 1. Try different architectures. Add more LSTM layers or use bidirectional LSTMs for better performance. Keycap 2. Use a pre-trained embedding like Word2Vec or GloVe instead of the built-in Keras embedding layer. Keycap 3. Experiment with different datasets, like Twitter sentiment analysis or news classification. Keycap 4. Tune hyperparameters. Adjust the learning rate, batch size, and number of epochs to find the best combination. Asterisk. That's it for this session. If you found this helpful, make sure to practice and experiment with different models. NLP is a powerful tool, and mastering it can open up many exciting opportunities. Keep learning, and I'll see you next time. Happy coding!